Okay, let's talk about intersection of two linked lists. So you are given the head of two single linked lists, head A and head B. So return a node at which the two lists intersect. If the two linked lists have no intersections at all, just return no. So imagine there's a point, a head A and head B, right? So they will meet at C1, right? So you will just return C1. And there's no guarantee cycle, right? So imagine 41845, right? 41845 is the linked list A, and 561845 is the linked list B. Then they intersect with node 8, right? So just return 8. So let's jump to the diagram first. So I have pointer A and pointer B point at the head A and head B. So I will just traverse the linked list one by one. So I will move A by one, B by one, and A by one, B by one, and A by one, B by one. If the value are the same, if the node are the same, I just return A or B, doesn't matter. So what happened to this? Have intersection and different length. So A and B, linked list A and linked list B are different lengths. So let's do it again. So I will just traverse the linked list A for A, linked list B for B. So A, B, and I jump one again. So I jump one again, and I'm keep jumping. I don't care. So I keep jumping. So if I jump my A from C3 to null, so if my A equal to null, right, my A will point at the B one. So when my B equal to null, the B will point at the A one. So they will do the traverse again. Since they are different lengths, so when they traverse the different linked lists, and they will definitely meet at some point. So which means in this case they will meet at C1. So just follow the diagram, and when they meet, just return A or B, doesn't matter. So have no intersection and same length. So when they are no, when they are not in, when they don't have the intersection, and then when they meet the no, right, they can actually just return no, because when both are no, right, which means they are no, right? So this is the idea. And how about have no intersection and different lengths? So it's the same idea. You have to traverse the other linked list, and they will meet each other when they add no, right? So that would be the idea. So how do you code it? So let's think about it. So the best case is this: head A equal to no, or head B equal to no. So you will just return what? Return no. It doesn't matter. The base case, one of these is no. You don't have intersection. So what do you actually do? You have this node A point at head A, B point at the head B. So while A is not equal to B, so this is how I traverse, right? So my A will become, if A equal to no, if A equal to no, I will have to point at head B, right? Otherwise, I just keep moving next. B equal to, so B is the same idea. If B hit nodes, you have to point at head A, and otherwise just keep moving and just return either A or B. So let's run it and see what happens. Alright, it's good, right? Alright, so let's talk about time and space. So what's the worst case for the questions? The worst case for the question is you traverse A, you traverse B, right? So when they have different length. So what would I think is, I would say like is either imagine the length of head A is m, and the length of head B is n. So there will be the m plus n time complexity, and the space complexity you are not using any space for sure. So that will be all of 1, and there is a question for the there's a solution for the question, and hope this helped, and goodbye.